How to use ratios to find similar polygons. And we talk about similar in math. It doesn't just mean they're the same size and shape. It means that actually they're equivalent kind of ratios or equivalent fractions. That whatever the difference between this size and that size is, that they're mathematically the same. And that is what we call similar. The symbol for similar in math is kind of like a wave or a squiggle. So here we have these two rectangles over here. This one must be some large piece of land or whatever. It is 36 kilometers in width and 68 kilometers in length. Down here we have one that's 12 meters in width and 17 meters in length. So I have to figure out how we go about figuring out if these are similar or not. Well, one thing you'll see indicated in some of the problems you do is you might see hash marks. So for example, this might have a single line and that might have a single line across from it. If you see that the parallel side has a similar indicator or a similar symbol, that means that they're equivalent. So this is 36 kilometers. You can be sure that this one must also be 36 kilometers. But they don't need to rewrite that. Instead, they use this marking. So if you saw a symbol with two hashtags or two lines, and down here is another mark with two lines, that just indicates that that is also 68 kilometers. So it takes the guesswork out of it. You can be sure that it's accurate. And here I'm going to do the same thing. One there, two there, and two there. And that'll tell us that it's actually those sides are congruent. They're parallel and equivalent. Okay, so now we get started. The next thing I need to do is, if it hasn't been done for you in the worksheet, the test, the book, or in life, we need to label each section. So I'm going to call this side or this length AB. I'm going to call this one B to C. This one over here C to D. And of course this would be D to A or A to D. It could work either way. So make sure you put markings on each of your corners or each of your angles if it's a triangle or some other polygon. I'm going to do the same over here, except I'm going to do, let's call it D, F, G, H, and I. So that distinguishes between those two rectangles without any errors. Now, the next thing I do is I set up my work similar to the way we did it over here. I write out my ratios as pairs of sides. So in this case, there's probably going to be 4. Do I need to write out all 4 sides to figure out if it's similar or not?
Yes.
I do?
Yeah. Oh, no.
There's 4 sides to this rectangle, right? Do I need to figure out all 4 sides, Kirk?
No, you only need to figure out 2 because a square or a rectangle is basically put together and this time will be exactly the same.
If I've had these symbols that tell me that both sides are equal, I know that this side, if I figure out the ratio between this side and this side, that it must be the same on both of these sides. So I'll show you what I mean by that. Let's demonstrate it instead of just talking about it. Over here, I'm going to put A, B, A, B, that's that angle over there. And the length over here, of course, is going to be BC. And I go ahead and I look at my other rectangle, my smaller version over here, and I ask myself, what is the equivalent to AB on this one? Well, of course, it's this length over here, or width over here of F and G. So I'm going to write that like this, F, G. Those are the pairs, those ratio pairs. And the BC, the equivalent to BC over here, of course, is G and H. I now know what I'm talking about. And I've set myself up for actually using the real numbers now. So, of course, the real number for AB is 36. And the real number for F and G that I've indicated over here is 12. And on the other side, the real number for B and C, of course, is 68. And the other number over here for F to I is 17. Is that right? Yeah, G to H, but it's the same as F to I, right? It would be the exact same length over here. So, here's what I need to figure out. I need to figure out if I can reduce these to simplest form, and then find out if I can do that, are those simplest forms the same? If the simplest form of each of these fractions or ratios is the same, then it must mean that these two polygons are similar. If what I come out with at the end, if these ratios or these fractions are not the same in simplest form, then they're not equal or not equivalent, not similar. I would just put not similar, okay? So let's figure it out. I have 36 over 12. There's something that both of these numbers can be divided by. I feel like there's a common divisor between these. Anybody, Nate, what do you think? 3? 3 is a good number? You're right, but I would have to go again if I did 3. You're right, though, it is, but I'd have to do it again.
12.
12. So I'm going to put divide by 12. Of course, I do the same to the top. And what do I come out with over there? 1/3.
No. 3.
3. Oh, yep, you're right. You're right. It was. We know starting off that it was an improper fraction, so we have to reproduce that the same way. 3 over 1. Yeah, which is actually equal to 3. But yes, so we have 3 over 1, or 3 is our over here. And can anybody see the ratio on this side? Is there something they're divisible by?
17.
They're both divisible by 17. Okay? And what does that give me if I divide both by 17? Thomas?
4 over 1.
4 over 1. Okay. So I have my 17, and they both broke down into exactly 4, divisible by 17, and my 12 divisible by 1. Are these two equivalent? Or I should say, are they similar?
They're not similar.
They are not similar. They are not. Okay, and that's it. Thanks, kid.